Hello. In this video, we're going to be talking about chords of a circle. Now, a chord is a segment completely within the interior of a circle, and the endpoints of a chord lie on the circle itself. So in the example below, segment MN is a chord of this circle because M and N both lie on the circle, and the rest of the segment is within the interior of the circle. So one thing we know about chords is that a radius can bisect it. That means cut into two equal parts if and only if the radius is perpendicular to the chord. That is to say, if OP is perpendicular to MN, that means MN must have been sliced completely in half by OP. What that also means is that this radius OP is also cutting arc MN into two equal parts, so that arc MP is the same as arc PN. Now, I'm going to add that information here, but make sure you get this copied down so that we can say the measure of MP is equal to the measure of PN's arc. So get that copied down, and I'll meet you on the next slide. So in this example of circle O, MQ and QN are both equal to 12. OQ is equal to 5, and we're asked to find the radius of the circle. Now we have a radius drawn right here. OP is a radius of the circle, but I don't know anything about QP in order to find the whole segment. What I do know is that because OP cut segment MN a chord in half, that means that we have a right angle here because we must be perpendicular. So what I can do, I can draw in another radius. I can connect from O to N, and I have a right triangle in order to find the length of ON. So OQ is 5, QN is 12. I can set up using the Pythagorean theorem, right? So A squared plus B squared equals C squared. A is 5, B is 12, and C is what we want to find. So we have 25 plus 144 equals C squared. 169 is the sum of 25 and 144. And when we square root both sides, only needing to focus on the positive version of this, 13 is equal to C. So the radius of this circle is 13 units. Okay? So that's a basic crash course on chords. For now, we are done.